Thank you. Thank you, Patrick. Thanks to the team that put this together. Patrick asked me a couple of weeks ago what I was going to speak on, and I had a couple of different ideas. I thought about maybe doing another run at Platform SSO, but I didn't know that there was enough stuff in there. And Eric talked to me and said he wanted to do something with it. So, Eric, wherever you are, make me proud. All right, maybe he's not here. Maybe it's better if he's not here. All right, so he's got a session on Platform SSO. So I thought maybe we could do something maybe a little more nerdy, a little more like in the weeds with some certificates and how you get them. I think it's an appropriate time to be starting to talk about ACME. Our friends from another company that were here before me and not recorded made some mention of managed device attestation. And managed device attestation entirely requires ACME certificates. So it's probably an appropriate time to dive in a little bit more and understand a little bit more about what ACME can get you, how it differs from some of the other ways of providing certificates. So I told Patrick I would do a session on this, and then, you know, he of course wants to know like a synopsis to put on the little web page, and as a speaker you have to come up with kind of a pithy little title. You know, how can you make certificates exciting? And I fear I have made a grave mistake. So probably nobody gets this, but I don't know, it's the first thing that came to my head, which probably tells you something about me. So this is, who knows who that is? The Smiths, right? So there's a few of you out there. That handsome gentleman in the sunglasses is Johnny Marr, guitarist of the Smiths, right? That very emo-looking, deep cut to the shirt is Stephen Morrissey, who went on to become Morrissey, maybe a little more complicated after the Smiths. So anyway, they had a song called Ask that uses the lyrics, ask me, ask me, ask me, which kind of sounds like acme, acme, acme. And yeah, I think I made a grave mistake. All right. All right. It happened to be a single. It didn't actually show up in any of the studio albums, so it was a little bit weird. But the B-sides were Cemetery Gates. Who knows what singles were? They came on these little pieces of vinyl, and you had to flip them over at times, and then the Cuss single came out after that, which was also weird. So anyway, so that's the album that's on. It's going to become, at first, I wanted this to just be a gimmick about the name. It has turned into more of a pathos about the subject, though. And so I will try to deliver that as we go through this session. All right. You always like to start with a figure that's challenging and gets everybody in the mood. My guess is 99% of admins hate dealing with certs, right? Am I wrong in that? There's at least 99 hands in here. You've got 99 problems and certs aren't one of them. No, they probably are one of them, right? So let's go in, let's talk a little bit about certs, kind of how you get them, and then we're gonna end up with some thought processes at the end to take you kind of through maybe how you should feel about some of these things. So first, before we get into certs, we gotta talk about PKI, right? So I have one slide on this. It's really big prime numbers. You can encrypt and sign with it. RSA and elliptical curve, don't worry about those. If you need any of this information, I'll tell you it during the slides. We're not gonna get into the crypto too much. And then Bob has a public key, Alice has a private key. If you've been through any crypto training, Bob and Alice show up a lot. They like to send a lot of encrypted messages to each other. And I don't know what they're talking about, it's encrypted. So anyway, you've got a private key and a public key. That's really not relevant for us, but I just want to put it in here because it would feel slightly wrong not to at least mention public key infrastructures, and we're going to talk about stuff. Two ways to get certs on a device, at least if you're going to have it pushed through a profile. So Apple provides profiles that allow you to take a pre-created cert with everything in it and push that down. That's one way. We're not really going to talk about that today because that you can already do. Easy, right? Create a cert, find out how to figure that out, push it down to the device. Instead, you probably want your devices to get the certs on demand or when they need them, when you push that profile, and there's two major ways of doing that. And the first one is SCEP. So SCEP stands for, hey, all right. This is going to be harder when it comes to ACME. Yes. So SCEP is Simple Certificate Enrollment Protocol. SCEP, the joke is the S stands for secure. It doesn't. It stands for simple. Although it's interesting, if you read the RFC on this, who's read the RFC on SCEP? Well, we're going to read it here today some, all right? Because it's actually a more enjoyable RFC than you would expect. Maybe your expectations would be low about RFCs and enjoyability, but it does have some gems in there. The original draft for this was done in 2000. Cisco apparently commissioned VeriSign to make it. Cisco needed certs for routers and other things, and so they came up with SCEP to be able to handle that. It is mostly unchanged in the last 20 years, 24 years, since it has kind of appeared on the scene, which is one of the reasons why it's kind of become a little bit of an issue. It was definitely designed to be secure at the time, but it isn't maybe considered so much anymore. And that's not its fault, it's just our ways of thinking and everything else has progressed since then. It was mostly why we know about it as Mac admins. We can probably blame Windows Server 2000. I mean, we can blame Windows Server 2000 for a lot of things as Mac admins, but we can definitely blame Windows Server 2000 for SCEP. So it was the first real commercial way to get certificates, and all from your Active Directory certificate authority, which in the Microsoft world is NDES, Network Device Enrollment Certificate. And Microsoft went as far as, you'll see in the log files and things like that, it's MSCEP from Microsoft SCEP. Because I think at the time it wasn't really finalized, so they did what Microsoft likes to do. If you care, it's RFC 8894. You know, don't wait, you can go look it up right now and read through it. But it's got this little gem, I thought this was pretty funny. Specification has spent over 20 years in the draft stage with its original design goal for routers and other things. We've greatly progressed beyond that. You can read the rest of it, but the sparkler is at the end. If OpenPGP was described as a museum of 1990s crypto, then the SCEP document was its graveyard. A place where crypto goes to die. That's in the RFC, it's kind of fun. Like I said, in a more enjoyable RFC than most people expect. And I even have the link to it down in the bottom, so if you get these slides later, you can see what we're talking about. So I have a timeline, so I wanted to kind of present this all within a, so here's today, right? We're at the far right of the spectrum. This is when Windows 2000 was released to manufacturing, 1999, so 24 years ago, 25. This is when the first submission as an IETF draft came out in 2000. It was never actually ratified. So SCEP that we've been using, that has been powering our entire internet, that you've been using for wireless certs, for VPN certs, for a lot of other stuff, was never official. They took another run at it in 2015, and now finally it's an RFC out there. So it kind of lived in this really weird nebulous area. And just so I can get us back to the whole title, the Smith single of Ask came out in 1986. So it's actually closer to this alternative rock single than it is to today, or just about in the middle there, right? So just some perspective of where all these things fit. So it started in Windows 2000, and it's been 9,055 days since the Windows 2000 RTM, which seems like a really long time to be using the same protocol in this world, right? TLS has progressed from SSL to TLS, from 1.1 to 1.2 to 1.3. We've got a lot of other protocols that progressed, but we're still a lot of people using SCEP on a daily basis. Now, I know this is Mac sysadmin, and we have our own special way of equating units of measurement. So I said, how long is that in bananas? Which then got me into a weird flow on some scientific articles on the post-harvest shelf life of bananas that I had to pay to actually read what the post-harvest shelf life of bananas were. I was intrigued by how bananas and guavas are the same, but instead I went, of course, to ChatGPT, which kind of told me it's somewhere between 2 to 5 to 12 days. You had to consider if it's in the fridge, is it at room temperature? So I now present to you that SCEP has been in use for 754.5 average banana lifetimes. And I believe an average banana lifetime is about 12 days. So that gives you an idea of how long we've been using SCEP. Cool. All right, SCEP in 30 seconds or less. Client says hello, client gets a CA cert, client encrypts a certificate signing request, which is a PKCS1 blob, with the CA cert into a PKS7, then signs that PKS7 with a private key using the CSR into another PKCS7. I probably did 30 seconds or less. In Sweden, do you have the concept of a turducken? So a turducken is the concept that you like turkey, you like duck, and you like chicken. And if you put a chicken inside a duck inside a turkey, and you cook it all at the once, you get a turducken. And I believe it was made famous by a Friends episode. Or maybe it was famous before as a Friends episode or whatever else. But this ends up being a bit of a turducken in that you have a PKCS10, which is your certificate signing request, wrapped inside an encrypted PKCS7 blob, which is wrapped inside of another PKCS7 signature. And so you end up with quite a few things. When I tried to localize turducken, because I probably figured that Nordic people, the folks who are going to be here, would not maybe have a long history of a Thanksgiving with turducken. I got a cannabula inside a cannabula inside a cannabula. I tried to get concentric cannabulas. It looks a little bit like a bad Twilight Zone episode. So anyway, so you have this first PKCS10, that's your CSR. That's the thing that you really expect is going in. That's where the client has created a key pair for itself, generate a certificate signing request, but it's got some way to protect that. And this is an interesting fact. SCEP was designed in a world before HTTPS was commonplace. And so they needed a way to protect the actual payload that was being sent. So you would have a CSR, you'd get a certificate from your certificate authority, you'd use that to encrypt the CSR. That's why it has to use RSA keys for the CA, not ECC. That's a different story, but I told you we wouldn't get into the crypto much, so we're really not going to talk about that. It would get encrypted, that would get passed into this PKCS7 blob, that's the encrypted data you see down there. And then that would be signed again to prove that the client encrypted this with the cert from the CA to actually put this thing in. Again, it's kind of layers in there. The thing that you need to care about is that there is what's called a challenge password. And pretty much the only thing that really authenticates this whole interaction is a plain text challenge password that gets added into the certificate signing request. When that CSR gets sent to the CA validates that challenge, and if you're good, you get a certificate. If you're not good, you gotta go try somewhere else. There's no provision for modern authentication. There's no provision for MFA. There's no provision for a lot of what we consider modern, or maybe even not even modern, just contemporary authentication in these flows. So this is why we want to do something more. This is all leading into why we're moving to ACME, is that SCEP has maybe some issues. So let's have a little fun. Whenever you want to learn something, you build a server for it. So this is a SCEP server we've got here running on my laptop. So you can see kind of all the stuff flying through there. I got a little app I made to do some stuff, and you can see this was bad AI, because this, not only are the hands bad, there's definitely an extra one in there. So here I can go to my organization. We'll load this up. There you go. Mac sysadmin 2024. I've got a SCEP server. I'm going to go in here and I'm just going to issue myself a challenge. You can see we got some traffic going on there. Whatever. Hello from Gothenburg. ERG, right? Man. And we're going to make it for 10 days because we're also going to see a fun little thing that happens here. So I'm going to generate a profile. That profile, then I'm just going to load onto this machine. You don't need MDM. You don't need DDM. All this kind of works pretty easily. You can just double click and go. So hello from Gothenburg. I'm going to save assigned profile, save it down into documents, go into documents, and there's the SCEP profile, right, that I just saved. Perfect. Today at 12:20, yep. Double click, it's going to take me into here. You got to do this little dance. Then you got to go remember where all this stuff is. Again, I think it's general device management. And here I've got a profile that's waiting for me. It's signed, it's got some settings associated with it. In here is a challenge. Luckily, Apple is no longer showing you this in the UI because the challenge is, at least in theory, sensitive, secret. So it's in the profile though. If you just open up the profile, you'll be able to see it. And if I hit install, it should ask me for my password. There we go. And then you're going to see this text down at the bottom kind of flow. So it's doing the actual PKI bits, and it's getting myself a certificate. You're going to see a big blob of purple in a little bit. That's the CSR. I'm going to sign it into a certificate, and then I'm going to have a certificate down here very shortly. If everything happens, there's a 200 with a post. And there we go. So now I have a certificate. It's unverified. Who knows how certificates get renewed on the Mac? It's a trick question. They don't. All right. One of the things to consider, we're going to cover this a little bit in the end. So the user actually does get prompted. I made a certificate that was good for about 10 days. So it expires on October 11th. It will not automatically renew itself. There's goods and bads to that concept. But if you're expecting the certs to automatically renew, you're going to be sorely disappointed. SCEP does have some abilities to provide for that. Not a huge amount, but it's in there. But in the Apple world, whether you're on a phone or a Mac, you do have to have the user go through and actually manually hit this update. The best thing that you'll get is you will get this little triangle warning that you've got there. So where does this cert go? Since I'm just using local profiles, this ends up in the system keychain. And there you go. This is the cert that was just issued a few seconds ago. Common name up here, some other things that are in there. So pretty basic, what you're probably used to. And it works, right? You have a cert. The certificate can now be used for wireless, can be used for other things as we go through here, right? So this is probably the world that we've been living in for the last 20 years. But, you know, maybe we can do a little better than that. So in the world of SCEP, we've talked about the static challenge. That's what I used here, which is the same for every client. There's another way of doing this, which is maybe seems a little more secure, because that way you don't have to have your entire fleet using the same SCEP challenge, because if somebody were to get that, then they could just start getting their own certificates. Keep that in mind. We'll talk about that at the end of this presentation as well. So instead, a lot of people, smart people, came up with the idea of dynamic challenges, where you could go in and create either a unique challenge that was time-bound for a specific amount of time, so after an hour it couldn't be used anymore, or you would specify a unique challenge per device. Since the SCEP protocol was never really ratified, never really got that far, there was no real established protocol for this, so what a lot of people did was actually just replicate what Microsoft NDES did. And so you were using, if you went to some of the MDM services 10, 15 years ago that were doing this, they would have NDES support, literally doing a web connection using an NTLM authentication to your Microsoft NDES server, and then screen scraping the result, which would get you a challenge out of it. I regret to say I actually wrote scripts that did this when I was at Apple, and we distributed them to some very large places that would just literally use curl and then parse through the HTML. So that was the best we had because, again, there was no concept, no idea here. When Cisco developed this, if you look through some of the Cisco documentation, it actually suggests you go to your network administrator where they will hand you a piece of paper with the challenge on it. You would then go to wherever you were connected through those blue console cables into your Cisco router, and you'd punch it in. And that was a secure way of doing it because it was an out-of-band connection, between these systems. So then as it got a little more advanced, people started glomming onto here. We've progressed a little bit since then, but not a huge amount, although I will say, and I know there's some folks in Microsoft here, and I hate giving them props, but they're actually doing some kind of cool stuff where, because the SCEP challenge is so nasty, if you use Intune as a MDM and you want to connect it to a CA, Intune will actually, instead of creating a unique challenge per every device that's something the CA maybe knows, it instead creates this encrypted blob. And then encrypted blob gets sent as the challenge, it gets sent back up to the CA, and the CA phones back into Azure Intra, what do we call it? They don't know either? All right. So it goes back into Microsoft and validates that challenge to determine if they should get a thumbs up or a thumbs down about this, right? Works out really, really well, and you don't have to have a lot of cross communication, because otherwise, if you're using, Jamf has the Jamf Infrastructure Manager, there's some ways to use that. I think some of the other services have that as well. That ends up being a proxy. It's a service account, but it's going back and then pre-creating the certificates, all right? And so they're pre-creating the certificates with a service account back into NDES or whatever the CA is, and then they're pushing them down individually. That works, but it also means that the private key is escrowed or it leaves the device. So in a perfect world, you want to do something where the client is actually pulling. So proxy is one way. Here's the Microsoft way that I was talking about before with the encrypted challenge. It's kind of cool. Microsoft has documented it. It maybe would be cool if it actually became a protocol and we could use this a little more relevantly. But I get why they didn't, knowing that it's taken 20 years to get SCEP where it is today. Here's a fancy diagram about the Microsoft stuff. Go look at it later if you want to. But yeah, pretty cool way. All right, so that's SCEP. That's been our experience so far. So what are our other options that are out there? Who knows what EST is? Eastern Standard Time, yes, but not for this. EST is Enrollment over Secure Transport. Cisco got kind of peeved that SCEP really didn't go anywhere and maybe didn't have as much going on for it as it wanted to. So they came up with something called EST, which is kind of like SCEP, but modern. It's got a well-known endpoint, which is kind of nice, so you can figure out where you need to go to. It has HTTPS as a requirement. What a concept for getting certificates that you would need maybe a secure connection to be able to do it. That's a little bit flipped because when it started, there was no idea of publicly trusted certs. So I get why it wasn't that way, but we've progressed since then. There's good support for it, but and here's RFC 7030, and just because we're doing this, we can show you. All right, so that was the first SCEP RFC in 2000. Smiths were in 1986. The EST RFC came out in 2011. So it actually started before the last iteration of the SCEP RFC is out there. Cool. All right, so that's EST. Never worry about EST again. There's no built-in support on the Mac. It's primarily, from what I can tell, used in routers and other things that Cisco has. Anybody ever done an EST cert? Let the record show there are no hands up in the audience, even in the upper balconies. So as a Mac admin, you forget EST. Don't worry about it. So I did it too fast. What does ACME stand for? It's got to be a backronym, right? Automated Certificate Management Environment. Rolls off the tongue. All right. Taylor Swift have a song about ACME? Maybe? She has a lot of songs. ACME's cool. It's got its own logo. Yay! I don't think SCEP had a logo. ACME really didn't start, I don't think they ever didn't want it to be a widely used protocol, but it was the brainchild of Let's Encrypt, which is part of the Internet Security Research Group, which is made up of Mozilla, the EFF, University of Michigan, Cisco, and Akamai. And Let's Encrypt is really, really cool. Who's used Let's Encrypt certs? Yeah, most of the room. Let's Encrypt is really fantastic. There used to be a time, young admins don't remember this, But there used to be a time when you had to pay for SSL certs to put on your web pages. And because of Let's Encrypt, they decided that it was more important to have security on the internet than to create a marketplace for CAs. Fantastic. And so now Let's Encrypt is a public CA that will allow you to authenticate to them. You got to prove who you are. We're going to talk about that in a little bit. You got to prove who you are and that you have control over the resource, and then it will issue you an SSL certificate. And it has made developing web services and everything else much, much easier, because you can now spin up new web services without having to worry about, do you have an SSL cert for that, and then spending $100 with somebody else. It's also started a trend of having much shorter lifetimes on certificates, because it is so easy to get. If you are a public host and you want people to come to you, you want people to trust you, there's a lot of value in having your SSL certificate being rotated very often. And I think the default for Let's Encrypt is about 90 days. All right, so one, if you have a web service and you forget about it, and maybe it got compromised, if somebody steals that certificate, it's got a very limited shelf life for when it might be a bad thing. Two, they've built a really nice automated way. Hey, automated in ACME stands for automated. They've built a really nice automated way to renew those certificates to be able to support that. And that's where ACME came from, was 100% to support this new way of generating certificates and giving it out to all these web services that are out there, and to make the web a more secure place. So it's a publicly trusted CA. You're probably using it on a daily basis, whether you know it or not, because, and it's RFC 8555, Let's Encrypt mints about 4 to 5 million certs per day. I couldn't figure out a way to equate that to bananas. So you're gonna have to, in your mind, a lot of bananas. Whatever it is, it's a lot of bananas. So 4 to 5 million certs a day, and even more, when you look at their stats page, they have about half a billion domains that are protected by a Let's Encrypt certificate. So 500 million people out there have gone out, used Let's Encrypt through ACME to get a certificate. So this shows a huge amount of emphasis on doing this, but probably very few of us in this room have ever used it for a client authentication. You may have used it to secure a web page. You may have used it without even noticing. If you're running a WP, a WordPress site or something like that, it may be getting a Let's Encrypt cert for you automatically. But you've probably not used it to actually go on your Mac or go on your iPhone and get a certificate. So ACME, modern and sane, all right? Client discovers all the ACME server endpoints. We're gonna show you how to do this in a little bit, so you can go figure that out for yourself. Client creates an account with the ACME server by sending a public key. So there's this concept that before you can ask for a cert, you've got to create an account with the remote server, with the CA. And the way that they do this is more of a tofu model, trust on first use, where anybody can come in and say, here's a public key, make me an account. Cool, you have an account, but you can't do anything with it. When you go to create or ask for a certificate, you do what's called creating an order. And when you create that order, the CA comes back to you, the certificate authority comes back to you and says, okay, you want a cert for apple.com, you're gonna have to prove to me that you have some form of ownership of apple.com. Because if you don't own it, I'm not gonna give it to you. So there is much more of a two-way trust that's being done here, whereas with SCEP, it was kind of like, if you knew this challenge, we'd do whatever. Now this is a lot more sane about how we go through this process. So the server then tells the client how to solve a problem. And in most cases, that problem is either a DNS record or hosting something on your web page. If you can do one of those two things, then Let's Encrypt is going to give you a certificate because you've proven that you own the DNS domain that the certificate's going to be associated with. All right? I have a web page, joel.com. It's not mine, so I actually have no idea what's there. So careful now. I have no idea if that's safe for work or not. But so let's go with example.com. I've got a web page, example.com. I need a certificate for it. I go to a Let's Encrypt service. I create an account. Great. I then say I'd love to create a certificate for example.com. It will send back something that says, here's this random piece of text. you have to put that either in a TXT file or you have to host it on that web page. Either way, doesn't matter. But if you can prove that you have administrative access to that service, then I will issue a certificate for that DNS domain. Cool, easy, smooth. Let's Encrypt has a lot of client tools. Certbot is one of them, I believe, that works out really well. If you're running a bunch of Linux servers, you do some web development, you just use Certbot, it takes care of everything for you. It's fantastic. You may be beginning to understand that this doesn't apply that well, though, to a client system that we're mostly dealing with. An iPhone or a Mac is most likely not attached to a DNS name. I mean, that was we haven't really done that for 10, 20 years, right? And it's probably also not attached to a web service. And I mean, you could do that on the Mac. It'd be kind of a little weird. Every one of your client systems is run a web server to prove who it is. How do you do that on a phone, right? Things get a little bit more complicated as we go through this. All right, client completes the operation, submits a CSR. At the end of the day, it still comes back to a certificate signing request. And if everything works, the server replies with a signed certificate. There are three, actually there's a fourth one, but we're not going to talk about the fourth one because it doesn't matter. There's three main ways of doing this approval. The first two are actually codified in that RFC 8555, all right? And that's an HTTP and a DNS request. So if you phone in, you say I'd like a certificate, the certificate authority goes back, says great, set up a TXT record at a whatever .yourdomain.com, whatever you're trying to register that cert for, or it says host this blob on a page that I can reach publicly, right? So it also makes it complicated for doing any sort of internal work. So those are the first two. And then in the last 2 or 3 years, it started off with a gentleman from Google, but Apple was kind of sniffing at this at the same point. And so they both progressed to kind of putting some emphasis behind device attest. So our friends from the company who can't be named before us mentioned this, and so we're going to get into this now. So this is a new addition to ACME. ACME's been around since about 2015. This has come out in the last 2 or 3 years. It is not yet ratified, so it does not have an RFC number for it, all right? But it is in use by Apple for all of the managed Apple device attestation. So what does that look like? Well, I'm glad you asked. Well, actually, we're not going to get there just yet. Some more notes on ACME security, just to give you an understanding of how much more secure and modern it is than SCEP. They do a fun thing called post as get. If you're running a web service or a proxy or something else like that, every connection that comes through you that has a parameter, query parameter, anything that's put in that URL typically gets recorded and logged. SCEP, everything is a query parameter, right? So it all goes in there, it's in your logs, it's blasted all over the place, and that's maybe not a very good thing. So every single ACME call is a post acting as a get. So your query parameters, anything else that you would do actually goes into a form post, and that gets posted to the remote site, just as a way of preventing any of this stuff from escaping into the logs. Every transaction gets a nonce, a unique random piece of data that then gets associated with the request that you have to go through there, right? This prevents any sort of replay attacks. We want to make sure that we only do one thing at a time, we do it in the right order, so that nonce really helps it. It also means that ACME transactions are a lot more chatty. With a SCEP transaction, it's only about 2 or 3 calls. You call get CA caps, get CA cert, and then you do your actual operation. With the ACME flow, you've got about 2 or 3 calls that you have to do just to get your account set up. Then you have to do 2 or 3 calls to set the order. You get told what to do. You do another 2 or 3 calls to actually satisfy that challenge. And then you can finally submit the CSR to the system. So there are a lot more moving pieces to it. It's not necessarily bad. In fact, it makes it more secure in the grand scheme of things. And everything is signed. It's the other big thing. With SCEP, it's just, hey, you're on the public internet, I can reach you, here's a request, right? The only thing that you really care about there is in the challenge. The rest is kind of irrelevant because it's made up on the fly. However, with ACME, everything's signed. In a fully functioning ACME world, and you will note, choosing my words carefully, Apple does not support this there's valid reasons, but in a fully functioning ACME world, once you've created an account with that certificate authority, you should never have to go through the process of proving who you are again. Because you've created that account, you've established some level of trust, you've proved yourself once of having ownership of a particular DNS name, great. So when you go in to renew that certificate after 90 days, you shouldn't have to go through the entire dance of reproving everything. Since that doesn't really apply to the client ecosystem and getting client certificates for devices, Apple doesn't do that, right? So just keep that in mind. They still have to go through the flow of creating that account for the ACME protocol, so they do that. It's just they'll never go back and reuse that account that gets created. So if you want to learn more about device attestation, that's Draft Device Attest 03. That's the IETF document down at the bottom there that you can go read on the plane ride back home. And to give you some idea, we're back to our little timeline. There's the Smiths, and EST was in 2011. ACME was in 2015. So we're actually, ACME and EST are before SCEP, at least again, the latest round of the SCEP RFC that has been made in RFC. But yet we're still using SCEP for almost everything that's out there because of the complexities and, to some degree, I guess, the newness. ACME's only been around for 10 years. Next year is going to be the year, right? Which is why we're doing this session today, to tell you all about it. So let's have a little bit of fun with ACME. So here we did a SCEP certificate, so you can see it all in there. I'm going to go in, and I've got back to my little certificate authority, and I'm going to go back here, and I'm going to go to SCEP, or ACME. And I've got some ACME challenges already created here. And if I go into my challenges, I've got one for my demo Mac, and I'm going to save assigned profile, replace. I had saved it before just testing. So first we're going to get rid of this one. Boom, gone. We don't need that confusing things when we go look in the keychain for certificates. So that one's gone. I'm then going to go back over here. That's keychain access. Going to go to the Finder. And here's the ACME profile. Double click. Perfect. Back to here. I've got a profile. Again, see basic stuff in here. ACME's got the concept, I think they call it a confidential ID. So it's got a unique identifier in it, but it shouldn't be treated as sensitive like a challenge in a SCEP cert is. But that's on here, it's buried in here. So I'm going to go back through, key type, ESEC prime random. And here's the very interesting thing. SCEP had no comprehension of hardware-bound keys or not. In order to do the managed device attestation that you really want to do with the Apple side, you have to have a hardware-backed key. So that means you've got a device that actually has a secure enclave on it, which is great because that's all the Apple devices that Apple's made in the last couple of years. So with that, I can use this profile to create an ACME certificate that's got a hardware-backed key that's in that secure enclave, which means that key is not going to be able to be used on another device. It's not going to be able to transit it to somebody else. I've got a high degree of confidence that this private key that's part of this certificate is on the device that it was created on. And that's the whole point of the managed Apple attestation, is that you actually get a statement from Apple saying that. So what I'm going to do here, I'm going to move this over, maybe make this a little bigger so you can see the scroll as it goes through there. I do an install, it's going to prompt me for my password. Prompting for me for my password. Oh, maybe it didn't. I've authenticated too soon. So now you see all the calls going back and forth. You see all the nonces getting checked. They're only used once. So every time it phones in. So now I just got my attestation from Apple. So I've proven to my certificate authority that I should actually be able to get this. The validated order is being processed. And now, finally, I'm going to send back the certificate authority, or the certificate that's being used. Almost done. There it is. All right. So there we have our certificate, and we can see that it's been installed. Again, it's got a 10-day expiration. For whatever reason, there's no, I think maybe Apple decided it was silly to even provide notifications that the cert was about to expire, because there's not even a little tiny triangle that the user won't know what to do with on the ACME cert. Just a note. So we have our certificate. A couple of things here. Since we did a hardware-backed certificate, we did ask for an attestation from Apple, and this is what we got back. During the ACME flow, the client goes through, creates an account, does all of that stuff with the ACME server. It then says, great, I need to get an attestation from Apple. It does a sideband negotiation between the client and Apple directly. Apple does whatever Apple needs to do to validate that it's a real machine. This won't work on a VM, which is why I'm using the actual hardware here. It's on a real machine. It's not a simulator. It's not been jailbroken on the iOS side. It's got some detections on that. And if all of those pieces pass, it then sends a signed statement. It ends up looking like a WebAuthn attestation, so they didn't have to remake attestations. So it sends that WebAuthn attestation back down to the client, and the client sends that to the certificate authority to be able to do this operation. So here you have all that pieces in here, and you can tell a lot of information about this device. In this attestation, and Apple's adding new fields to it all as it goes through, I know that SCEP is enabled, full security for secure boot status. I've got the model number that's used for software update. I've got the version of the OS. I didn't do the binary to strings very well for SCEP status and third-party extensions, but I know that third-party extensions haven't been enabled for this. So you do get a really good sense of information. Now, if you're using this just for a client certificate for maybe wireless or something like that, it's maybe not super great because you only get this one time. The only time you get this is when you mint the certificate. So if the OS version changes, you won't get any updates on that, right? You're gonna have to figure out how to manage that yourself. The cool thing is, MDM has the ability, my authentication to eduroam failed. That might get awkward. Luckily, the demo might be over. We'll see what happens here as that goes through. So that all works out really, really well, but again, it's not updated. So Apple realized this was an issue, and if you're using an MDM server that uses ACME for its enrollment profile, does anybody have an MDM server that uses ACME for its enrollment profile? Mark raises his hand, and this is when I told him I would call on him. Is that rolled out everywhere? That's what I thought. It's progressing. So if you are using Intune, based upon a certain number of things that Mark probably can't tell us, you may or may not get an ACME cert when you enroll. And I believe that's the only MDM service that I'm aware of that's using ACME certificates for enrollment profiles. And I have a bone to pick because I knew this was happening, but I didn't know it was maybe not all the time. And I paid $10 for an Intune subscription last week. And I enrolled a VM multiple times on the train between Copenhagen and Gothenburg yesterday, and I kept getting SCEP certificates. So it's very cool that Microsoft is going in that direction. ACME is a much better way. So my next question is Intune using the device information commands to revalidate the ACME attestation? The audience was not conclusive in his answer. All right, so the cool thing, if you do use an ACME certificate to enroll in MDM, the MDM service can occasionally go back to that device. Apple rate limits this because they know people are silly, and if given an opportunity to check something, they may check it every day. And instead you get rate limited, I think, to about once a week, where the MDM service can go back to the client and ask for a device information request. And in that device information request, we'll actually get back a new attestation like this. So it is actually a really cool way to get a signed statement from Apple at exactly what OS version you are and a few other things that are in there. So that's really cool. Now, where is this key? Well, if I go back here, when I had a SCEP certificate, it was showing up in the system profile or the system keychain. Sometimes you got to smack keychain access a little bit because it doesn't update, but I don't have any certificates in here. And this is the major reason why most people are not using ACME certificates today, is that you don't actually see them anywhere on the Mac. There's some really good reasons about the data protection keychain and how it's hard to expose a hardware-backed certificate through the mechanisms that Apple has through keychains today on the Mac. Most of that's covered on iOS already, and if we have time, I can show you all this working on iOS, which is kind of cool, and you can actually use it for some things. On the Mac, it's very, very limited. It doesn't show up in Safari. It doesn't show up in a lot of the other places that you would expect it to, all right? And this is probably why we have not yet moved to ACME. Mark has a question. This is my session, Mark. The questions aren't up yet. You can see it through the management profile, but I'm not using MDM. I'm just double clicking. I have a certificate on it. So yes, you can look into system info and stuff like that and see that it's landed, but it's pretty opaque to any application on the Mac that really wants to use it, which is a bit of a challenge. Now you can bundle it, I think, with some profiles, but I couldn't get that to work on the Mac. And I think maybe MDM is a requirement to get all that to fit in there. And I also think iOS is a bit of a requirement to get all that to fit in there. So you've got to have Apple Silicon. I think with Sequoia, they moved it up to not including some of the Intel systems. Prior versions, I think some of the Intel systems would work with it. So it started in macOS 14 Sonoma, and it started on iOS 16 that you could do this managed device attestation. So again, two ways to use ACME certificates: through MDM enrollment or just pushing it through profile later. MDM enrollment, you should absolutely start thinking about. I'm excited to see vendors start doing this because it does provide a much higher degree of security for your MDM enrollments. Plus, the more vendors start using ACME for MDM enrollments means the more just general authentication and use cases for ACME certificates are going to be out there, and we can move on from the last 20 years that we've been using SCEP, right? And the MDM server can do that through managed device attestation and pull there. If you just do it through a config profile, it is usable to Apple apps on iOS. So I can push this config profile to my iPhone. I'll be able to go to Safari, and I'll be able to sign in with that. So it can work. You can even use it as a certificate for VPN access, but it's really hard to get other third-party apps because sharing certificates like that on iOS gets very, very complicated. On the Mac, it's still restricted by a lot of ways, so it gets to be a bit of a mixed bag if you want to use this beyond the MDM enrollment. So, having done all that, we've got some guided Q&A. When I did the platform SSO session, I found the guided Q&A to be the best way that I can ask the questions that you should have asked but didn't, and make sure that I give you the right answers because I already know the questions. So let's go through that. Should I replace SCEP everywhere with ACME? Yeah. I wanted to have a much stronger answer to this, but we still need more functionality on the Mac side to be able to do it. The other wrinkle in this, and I played around with this some. I was going to put it into a demo, but I thought it would just confuse people more. There's no legitimate way to get an ACME certificate without the hardware-backed authentication. The hardware-backed key makes it so it's not very useful to a lot of the other apps because of the protections that Apple has between all the keychains. If you remove the hardware-backed requirement, I can break my CA so that I can issue those certificates without an attestation. But then it gets a little bit weird because you've really gone off the rails from any of the ACME RFCs or the ACME information that's out there. And it would be pretty much impossible unless you're writing your own ACME server to actually provide for that. So while I want it to be a really just widespread replacement for SCEP, the reality of it is we're just not there yet, which is why I want to see more people using ACME, more MDMs using it, so that we can then have a greater use of it across the platform, and then we can start finally getting rid of SCEP for a lot of these things as we go through there. All right? Is SCEP unsafe? I don't know. World's been running for 20 years with it. We got problems, but SCEP's maybe on the lower one of them. You just need to be very careful with SCEP. Don't use static challenges as much as possible. Use services that can do dynamic challenges that are out there so that you're not reusing the same one over and over again. Just have some thoughts about what you're using for SCEP and how it's being implemented in your environment. Should all my certs be hardware-backed? We now have some great opportunities for creating hardware-backed certs. partially because all of the Apple hardware out there has the hardware capacity to be able to do it. So is it a good thing if we have more and more hardware-backed certs? Maybe not, all right? There are definitely reasons to use hardware-backed certs, and for the managed device attestation is a fantastic one. However, you may have reasons to use certificates that are a little bit more flexible, that might be able to be moved around. On the Mac with the hardware-backed certs, you can't really share them between users. Maybe that's not what you're looking for, all right? So keep that in mind. As exciting as it would be for a world where all certificates are hardware-backed, maybe you don't have to worry about that. Should you ever think about EST again? Nope. Don't worry about it. Should we think of client certs like SSL certs? This is something that commonly comes up when you look at certificates for devices, right? You've got two major kind of groupings of certificates and what people want to do with them. The one that we mostly run into on a daily basis is for web pages. So using them for TLS, when we think about certificates for clients, it's usually referred to as MTLS or mutual TLS. We're using that client certificate as authentication. And I would argue that you should look at these two bodies much, much differently. On your web pages, rotate those certificates every 90 days. Get that a very common occurrence. Keep those going. On your clients, wow. Rotating every 90 days is just a recipe for disaster. If you like help desk tickets, if you like users calling you up wondering why they can't get on wireless, then have a really short lifespan on your certs, all right? But I just don't see it giving the same benefit because you're using it for client authentication. And one of the ways of thinking about this is if your client, like if your MDM cert expires, what are you gaining by not allowing that device to phone home to MDM? You have no way to fix that device. You have no way to push new things to it. So by limiting its access back to your MDM server, you pretty much caused yourself more problems as you go through here, right? So again, think of this very differently, both for the client certs as opposed to anything that you're doing on a web page or anything like that. So not really. And then, is ACME secure enough? No. And the reason why I say this, that's kind of a flip answer. ACME is just one part of your system, right? In the previous session, they did make some mentions, because this is all over a lot of the Apple documentation about how you should think of managed device attestation. And you very much need to think about defense in depth here, all right? Just because Apple at one time said that this key was created on a device that may at one time have had a working secure enclave, that was at least at the time, as best as Apple could tell, was not compromised, had not been rooted, had not been in any way messed with, does not mean that the device still has that same state months, weeks, years later, right? So just by the fact that you have a cert should not be the end-all be-all of accessing resources, at least not those that you want to keep at a higher level of security, right? If you want to use it for day-to-day use for wireless, for things like that you already have protections around, because just gaining access to wireless doesn't necessarily give away the keys to the kingdom, fantastic, do that. If you want to use it for something that's going to be maybe financial data or something that you've got to get regulators behind you, start thinking about defense in depth, and that's what a lot of that zero trust thinking is out there. However, I would say don't go crazy and try to start issuing 90-second certs for your devices, because that's just going to hurt. And it's turtles all the way down, right? You eventually also have to establish who you trust in this place, right? You think you're really doing great because you've got a managed device attestation from Apple, but you haven't been to Apple's factories. You haven't inspected Apple's source code. You don't know what's out there, right? And that's not to say you should, or it's not to say everything is scary, just run the other way, but more just think about where you're putting your box of trust around. At some point in time, you're going to have to trust a vendor. Very few of us in this room are capable of actually doing reverse engineering on hardware. Maybe a few of us, but not many. So you have to establish a box of trust. Establishing at Apple is perfectly fine because that puts the biggest turtle down at the bottom under your trust box. And so then using managed device attestation above that is a really great thing to do, but don't have it as your only check because, again, keep in mind that there's many layers here. How long should I make my certs for? This is a Cannibulin hot take that I'm about to give. You should make your certs for as long as you can, especially on your clients. Making your certs last as long as the hardware lasts is a great way of making sure you have fewer help desk calls. If you do have defense in depth with a number of other reasons why you're checking, making sure that device is still checking into MDM, making sure it's still been updated, making sure you've got all these other security protocols in place, then the last thing you should have to worry about is constantly rotating your certificates on your client devices. Again, I say that is not applicable to your web pages and things you would have be publicly accessible. So we come back. I was trying to, the last slide is the one you work on last, right? I was trying to circle this all back around to a Smith song. And the lyrics are, ask me, how could I say no? I won't say no, how could I? And ACME, I won't say no. Absolutely start thinking about ACME. It's becoming more and more prevalent throughout the Mac admin world. And there's no reason not to use it. However, there are some things that you still need to keep in mind. We're not in a place where I can immediately say, dump SCEP, get rid of all that junk that you've had, that you've accumulated over time, and immediately move to ACME. We need some more pieces in place. We need some more muscle to be grown in that space. And with that, I'm a minute or two over.
Thank you, sir.
Thank you.